Shalom class, welcome to Innocent MAPANDA tutorials. In today's lesson we are going to focus on series. I'm going to touch on method of differences as well as the Taylor series. Right. So this question was extracted from paper 2 Zimsec November 2018, question number 10. Right. We are going to start with part A. It reads, find summation, right, from r is equals to 1 up to the nth term of 2 divided by r plus 1, r plus 2, 6 marks, right? So what you need to do is you start by expressing the given fraction as a partial, right? So I'm going to write 2 over r plus 1, r plus 2. You can clearly notice that these are linear factors. So a is going to be divided by r plus b divided by r plus 1 plus c divided by r plus 2, something like this. I hope you are following, right? So you can clearly notice that r into the LCM, you'll be left out with r plus 1, r plus 2. Then r plus 1 into the LCM, you'll be left out with r and r plus 2. On C, you'll be left out with r and r plus 1, which is identical to 2. I hope you are following, right? So we are going to find the value of a when r is 0. If r is 0, we'll be able to eliminate b and c. I hope you are following, right? So on the a side, you'll be left with 1 in the first bracket, 2 in the first bracket, which is equals to 2. I hope you are following. So 1 times 2, you get 2. So this is 2a is equals to 2. Therefore, a is equals to 1. Then we can make use of r is equals to minus 1. This assists you to eliminate a as well as c so that you find b. I hope you are listening. So you are going to put minus 1 on r. Here you have minus 1 plus 2 to be equated to 2. Right? So 2 minus 1, you get 1. 1 times minus 1, you get minus 1. So this is minus b is equals to 2, which simply means that b is going to be represented by minus 2. Then we can eliminate a and b using r is equals to minus 2 so that we find c. I hope you are following. If you put minus 2 here, you eliminate a. If you put minus 2 here, you eliminate b. So we'd like to find c when r is equals to minus 2. So c here, put minus 2 on r, minus 2 plus 1 here, is equals to 2. I hope you are following, class. C, open bracket, minus 2. Minus 2 plus 1, you get minus 1. Something like this. So minus 2 times minus 1, it gives you 2. So on the left side, you have 2c is equals to 2. Divide both sides by 2. C becomes 1. I hope you are following, class. Right, so let us substitute the values of a, b, and c, right, so that we complete our partial fraction. So a is 1, so you have 1 over r. Then b is minus 2, so if you put minus 2 here, you have minus 2 over r plus 1, something like this. Then c is 1, so we'd like to put c here. You have 1 over r plus 2. So this is the partial fraction, right? So we are going to make use of method of differences. I want you to stay tuned. Right, now that we have expressed the given fraction into partial fractions, we can now use the method of differences. So for the method of differences, let us start by identifying the first 3 terms or the first 4 terms of the series, as well as the last 3 terms of the series. Right. So after identifying the first 4 terms, you will be able to identify the terms that are going to cancel off each other. The remaining terms, right, that we have not cancelled are going to help you to identify or to calculate the final answer. So let us start with the first term. The first term is going to be obtained when r is equals to 1. Remember, 1 is the lower limit here, right? So I'm going to put 1 on each and every term in r, right? So you get 1 over 1 minus 2 over, so 1 plus 1 you get 2 here, plus 1 over 1 plus 2, it gives you 3. I hope you are following, class. We move on to the second term. This is going to be obtained when r is equals to 2. So here you get 1 over 2, right? Minus 2 over 2 plus 1, it gives you 3. Plus 2 plus 2, you get 4. So this is 1 over 4. I hope you are following, class. Then we move on to the third term. The third term is to be obtained when r is equals to 3. So you get 1 over 3 here, minus 2 over 3 plus 1, you get 4. So you write 4 plus 3 plus 2, you get 5. So this one becomes 1 over 5. I hope you are following, class. For the fourth term, you obtain the fourth term when r is equals to 4. You get 1 over 4 here, minus 2 over 4 plus 1, it gives you 5, plus 4 plus 2, you get 6. So you write 1 over 6, something like this. So we are done, right, for the first 4 terms. Right, here I'm going to put a plus in front to indicate that this is a continuation. It's just that I'm writing my terms vertically, but it is a continuation sum of terms in a sequence. I hope you are following. Right, then on this one I'm going to put dash 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 plus to indicate that we have middle terms, right? So I'm now finding the last 3 terms of the series. So to find the third from last, you obtain the third from last using r is equals to n minus 2. Putting n minus 2 on r, you'll be able to identify the third term from the last. I hope you are following. So you get 1 over n minus 2. If you put n minus 2 on r, minus 2 over, putting n minus 2 on r, you get n minus 2 plus 1. It gives you n minus 1. Since minus 2 plus 1 is minus 1. I hope you are following. Then put n minus 2 on r plus 2, you get n minus 2 plus 2, which is n. So this is plus 1 over n. Right. Second from last is going to be obtained when r is equals to n minus 1. Something like this. I hope you are following. So you get 1 over n minus 1. If we put n minus 1 on r, minus 2 over n minus 1 plus 1, you get n. So it's now 2 over n here, plus n minus 1 plus 2, you get n plus 1. So plus n plus 1. I hope you are following, class. Then the last term is going to be obtained when r is equals to n. So I would like to put n on each and every r letter. So you get 1 over n minus 2 n plus 1, you get n plus 1 here. Then you put plus. Here we have 1 over r plus 2, so it becomes 1 over n plus 2, something like this. I hope you are following. All right. So we now want to cancel off the terms that produces 0. We can do the cancelling diagonally. You can notice that 1 over 3 minus 1 over 2 plus 1 over 3, they give you a 0. So these three terms are going to cancel off each other diagonally. I hope you are following. 1 quarter minus 2 over 4 plus 1 over 4, it also gives you 0. So you cancel off this diagonally. I hope you are following. So if we were to find r is equals to 5, you will find out that you are going to get 1 over 5 here, which is going to cancel off with minus 2 over 5 as well as 1 over 5. I hope you are following. Right. Then we move on to the last three terms. 1 over n minus 2 over n and 1 over n, they cancel off each other to give you a 0. I hope you are following, class. So I want you to notice something. All those terms in between this line and above this line, they are going to cancel off each other to give you 0. So we now ignore them since they give you 0. Right. So our final answer is now going to be made of terms which we have not cancelled above as well as below. I hope you are following. So we have three terms above that we have not cancelled, which are 1 over 1 minus 2 over 2 here plus 1 over 2. 1 over 1 minus 2 over 2 plus 1 over 2. Right, then below we have plus 1 over n plus 1 minus 2 over n plus 1. We also have plus 1 over n plus 2, something like this. Are going to help us to find the final answer. So 1 over 1 is 1, 2 over 2 is also 1. So it's good as 1 minus 1, you get a 0. So the first term becomes half. I hope you are following, class. Right, then we move on to this one. Since we have a common denominator here, it simply means that 1 minus 2, you get minus 1 over n plus 1 plus 1 over n plus 2. Since the common denominator was n plus 1 and n plus 1, you simply subtract the numerator. So 1 minus 2, you get minus 1. I hope you are following. Right. We now want to make these two as a single fraction. So let me start by writing the positive fraction first here. 1 over n plus 2 minus 1 over n plus 1. Maintain this half. So LCM here is n plus 2 and n plus 1. So n plus 2 and n plus 2, they cancel off each other, leaving you with n plus 1, which multiplies the one above. You get n plus 1. I hope you are following. Then you put a minus. N plus 1 and n plus 1, they cancel off each other. Then you multiply with this one with n plus 2, something like this. So this is half here. I hope you are following. Plus n plus 1 minus n, minus n plus, you get minus. So 1 times 2, get 2. All over 2 n plus 2 n plus 1. I hope you are following, class. So you can clearly notice that n minus n, they give you 0. 1 minus 2, you get minus 1 over n plus 2, n plus 1. And this is your final answer. I hope you are listening. We move on to item 2 of the question. It reads, hence or otherwise deduce the value of summation of 1 up to infinity, 2 over r plus 1, r plus 2. Right, so now that we know that this, we have simplified it to become 1 over 2 minus 1 over n plus 2, n plus 1, something like this in our previous question, right? We can make use of the limit theory, which says that when n approaches infinity, this entire fraction, 1 over n plus 2, n plus 1, it tends to approach 0. So if it tends to approach 0, it means that you'll be left with the half. I hope you are following. So the value is half. But you have to make this explanation. When n approaches infinity, this fraction, it tends to approach 0. So you'll be left with the half. And half is your answer. You get yourself 2 marks. I hope you are listening. Right. Part B of the question, it reads, use the series expansion of cos x to expand 1 plus x squared times cos x up to and including the term in x cubed. So the series of cos x, right, are there on your data booklet, the formula list, right? Cos x is equals to 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial. Then it goes on like this, right? But x to the power of 4 over 4 factorial, we're going to leave it. Why? Because we want to expand up to and including the term in x cubed. I hope you are following, right? As for 1 plus x squared, we just expand the way we do it, right? 1 squared, you get 1. 1 times x times 2, it gives you 2x. Then the last term, if it is raised by power 2, you get x squared. So 1 plus x squared, you get 1 plus 2x plus x squared, right? So 1 plus 2x plus x squared is going to represent this function. Then as for cos x, we are going to substitute cos x by 1 minus x squared over 2 factorial, where 2 factorial is good as 2 times 1, which gives you 2. Then this x to the power of 4 over 4 factorial, we leave it. Why? Because our limit is x cubed. I hope you are following, class. Right. So 1, here, this 1 is going to multiply 1 plus 2x plus x squared. Then minus x squared over 2 is also going to multiply the same bracket, 1 plus 2x plus x squared, something like this. So if you multiply by 1, you get 1 plus 2x plus x squared. Minus x squared over 2 times 1, it gives you minus half x squared. Minus and plus, you get minus. So you can clearly notice that 2 and 2, they are going to cancel off each other. So you'll be left with x cubed here. Then it is no longer necessary for you to multiply minus x squared over 2 with x squared, because it gives you x to the power of 4. Yet our limit is x cubed. I hope you are following. So if we collect like terms, our final answer in its lowest terms becomes 1 plus 2x, right? X squared is good as 1x squared. So 1 minus half, you get half. So this is half x squared minus x to the power of 3. And this is your final answer. So this is how you expand this to get the 4 marks. Right, but see, it is given that d squared y over dx squared plus dy dx plus 3y is equals to 0. Y is equals to 1 at x is equals to 0. And dy dx is equals to 2 at x is equals to 0. Right. Use the Taylor series, right, to find the first 3 terms of 1 plus x squared cos x 4 marks. Right. So what you need to do is you start by writing the formula of Taylor series. F of x is equals to f of a, where f of a denotes the first term, right, plus first derivative, then you put a, then you write x minus a, divide this by 1 factorial. I hope you are following. This is now your second term, plus second derivative, then you put a here, then you write x minus a squared, so that you divide this by 2 factorial, and this is your third term. Right, I would have loved to find the fourth term and teach you how to expand up to x minus a cubed for the sake of revision. So let me work the requirements of the question. It is requiring you to find the first 3 terms only, right? So what is f of a? Right, we are going to understand the meaning of f of a. F of a denotes the value of y at value, the value of y when x is equals to a, right? Of which you can clearly notice that y is equals to 1 when x is equals to 0. So it means a is being represented by 0. I hope you are following. And the value of y when x is 0 is 1. So y is equals to 1 when x is 0. And 1 becomes your first term. I hope you are following, class. So in simple terms, f of a is going to be represented by 1. Right. Then, to find this second term, first derivative of a, x minus a over 1 factorial, you need to find first derivative of a first, and this denotes dy dx. I hope you are following. So dy dx is given in the question. Dy dx is equals to 2. So I'm going to put 2 here. I hope you are following, class. So my answer is going to become 2 open bracket x minus, remember a is 0 in our question, divided by 1 factorial, which is good as 1. So your final answer for the second term becomes 2x. I hope you are listening. Then we move on to the third term. Second derivative of a, x minus a squared over 2 factorial. What is the meaning of second derivative of a? It is going to be represented by d squared y over dx squared. So we need to find d squared y over dx squared. We are going to be guided by the given information in the question, that d squared y over dx squared plus dy dx plus 3y is equals to 0. So d squared y over dx squared plus, remember dy dx is given as 2, so I'm going to put 2 on dy dx plus 3 open bracket, y is given as 1, so I'm going to put 1 on y, then equate this to 0. I hope you are following. You get d squared y over dx squared plus 5, which is 2 plus 3, is equals to 0. So d squared y over dx squared becomes minus 5. I hope you are following. So I'm going to put minus 5 on this. It means that your third term becomes minus 5 open bracket x minus 0 squared over 2 factorial, which is minus 5 x minus 0 squared to get x squared. 2 factorial is 2 times 1, which is 2. So minus 5 over 2x squared becomes your third term. I hope you are following. So it means my final answer for f of x becomes, in the first working for f of a, we found the first term to be 1. So 1 represents our first term. Then for the second working, which was first derivative of a, x minus a over 1 factorial, we got 2x. So I'm going to add 2x. Then for the third term, which was second derivative of a, x minus a squared over 2 factorial, we got minus 5 over 2x squared. So I'm going to write minus 5 over 2x squared. And this is my final answer. I hope you're right. But for revision's sake, what if the examiner wants you to find up to x minus a to the power of 3? What are you going to do to find up to x minus a to the power of 3? You then need to differentiate this given differential equation. I hope you are following, right? So derivative of d squared y over dx squared is d cubed y over dx cubed. I hope you are following. Then you put a plus. Derivative of dy dx, you get d squared y over dx squared. Then from the implicit differentiation, whenever you differentiate a term in y, you have to put dy dx in front. So derivative of 3y is 3, but 3 was in terms of y. Therefore, you need to write dy dx in front. Derivative of 0 is 0. I hope you are following, class. Right, so we would like to make d cubed y over the x cubed the subject of the formula. So in our previous workings, we managed to find d squared y over dx squared to be minus 5. So I'm going to put minus 5 here, plus 3 dot product. Then on dy dx, we are given by the question that dy dx is 2. So I'm going to put 2 on dy dx, then you equate this to 0. So d cubed y over the x cubed, right? This is now minus 5 plus 6 is equals to 0. So minus 5 plus 6, you get 1. So d cubed y over the x cubed plus 1 is equals to 0. It simply means that d cubed y over the x cubed, which is the third derivative, is equals to minus 1. I hope you are following, right? So you have to add the term here, which is third derivative of a, x minus a to the power of 3 divided by 3 factorial. So to find this term, third derivative of a, x minus a to the power of 3 over 3 factorial, you need to find the third derivative of a, and in our workings it was minus 1. So I'm going to put minus 1 here, right? Then remember our a is 0, so it's x minus 0 to the power of 3 over 3 factorial, which is good as 3 times 2 times 1, right? So you now have minus 1 x cubed here, 3 times 2, 6 times 1, 6. So it gives you minus 1 over 6 x to the power of 3. So if the question requires you to expand up to the term including x minus a to the power of 3, it means that on our previous answer here, you just simply need to add minus 1 over 6x cubed. I hope you are following. Right. Same applies. If you want to find the fifth term, or the term which includes x minus a to the power of 4, right, you have to find the fourth derivative, making the fourth derivative the subject of the formula, right? So remember, the initial condition or the initial differential equation was given as d squared y over dx squared plus dy dx plus 3y is equals to 0, right? So derivative of d squared y over dx squared, we got d cubed y over dx cubed, right? Then the derivative of dy dx is d squared y over, then we made use of the parametric that whenever you differentiate a term in y, you put dy dx in front. So the derivative of 3y was 3, but dot product dy dx. I hope you are following. Right. So to find the fourth derivative, right, you say derivative of d cubed y, you get d to the power of 4y divided by dx to the power of 4. Then you put a plus. Then derivative of d squared y over dx squared, it becomes d cubed y divided by dx cubed. I hope you are following. Then you put a plus. Then the derivative of 3 dy dx, you get 3 dot product d squared y over dx squared. Then derivative of 0 is 0. Remember, d cubed y over dx cubed, we found it before in the previous working, it was minus 1 plus 3 open bracket. Then d squared y over dx squared, in our previous working, we got minus 5. So I'm going to put minus 5 here. Then you equate this to 0. So this is d to the power of 4y over dx to the power of 4 minus 1 minus 15 is equals to 0. You get d to the power of 4y over dx to the power of 4 minus 16 is equals to 0. So d to the power of 4y divided by dx to the power of 4 is equals to 16. I hope you are following, class. Right. So here you put 16 for this term. So you get 16 covering this one. Then you write x minus 0 to the power of 4. Since our a was 0, 4 factorial is equals to 4 times 3 times 2 times 1, of which you can make use of your calculator to simplify 4 factorial. Right. So you write 16 x to the power of 4. 4 times 3 is 12 times 2. You get 24 times 1 is still 24. Divide this by 24. Right. So 16 over 24 can be reduced by 8. 8 into 16, you get 2. So this is 2x to the power 4. Then 8 into 24, you get 3. I hope you are following. So this one becomes your fifth term. Right. So it means on this one, you need to add plus 2 over 3x to the power 4, which becomes your fifth term. But here our question was requiring you to find only the first 3 terms. So our answer was going to become 1 plus 2x minus 5 over 2x squared. I hope you enjoyed the lesson. If you are watching for the first time, I kindly ask you to click the subscription button below as well as the bell so that you don't miss new videos when posted. Kindly invite as many subscribers as possible to Innocent MAPANDA tutorials so that they can also benefit before their final exams. Till we meet again, Shalom.